we are going to look at interrupts. Let me see if I have the manual. Okay, so this is what we're going to do for today. Meaning we will learn a bit more about interrupt handling. So in the first case, we're going to cover some basic and say incomplete usage of interrupts for SW3. Later on, we will look at the complete usage or complete method of using or SW3 interrupt. And then we're going to cover interrupts for the light sensor. And then later, maybe I'll have a small briefing for those who don't know how to use OLED yet. So let us get started with the very first briefing on how to use a basic interrupt. Now inside your program, okay, it's empty, let me import it. So I will import the original program. As well as our original demo file. Okay, I think should be fine. Okay, so remember last time when you had written your program, there was a place where you where you check whether a button has been pressed or not. For example, button 4. If you recall for your very first lab, this is an instruction which checks whether your SW4 was pressed or whether your SW3 was pressed, and you had placed it somewhere here. So what we had seen previously was you had a while loop. We did some instructions here, sequentially. Somewhere we check if the push button has been pressed or not. Then we do something and we have some other instructions. What had happened was the instructions were being covered sequentially. So it's over here that you were checking whether SW3 was pressed or not. Let's say if your program was running, and let's say somewhere here you have a complicated instruction which takes time, maybe 2 seconds, 3 seconds, and so on. So it's like during this time instant, it is not possible to check whether the push button has been pressed or not, because your instructions are currently being carried out sequentially. So when it is carried out sequentially, this is a polling mode. Meaning after some time instant, we're checking if the button has been pressed. So I will check, I will do something, I will move out, then I will come back again here, I will do the next instruction, check, proceed on, and continue forever. So this will continue. So basically every time you're checking whether your push button has been pressed or not. Now, the disadvantage of polling mode is, like we mentioned, if there's an instruction here which takes time, basically you cannot check if the push button has been pressed or not. How can we deal with that? Well, there's something we can do. Let's say, let's remove this instruction. Let's say there are some other things here. How do we check whether the push button has been pressed or not? We can enable our interrupt such that no matter where you are in your program, no matter which line is being carried out, anywhere you can check whether the push button has been pressed or not, whether it's here, here, and so on. There's a way to do that, and the way to do it is by making use of interrupts. Maybe you can compare the polling mode and interrupt mode. Let's say we'll take an analogy. Let's say for polling mode, or rather, right now, let's say it's 6:40 p.m. Let's say you need to go out at 9 p.m., which I hope most of us will go out at 9 p.m. today. So let's say you need to go out at 9 p.m. There are many ways you can check whether it is 9 p.m. For example, maybe right now you're working on your assignment. Later on, you check the time. So later on, maybe you will figure out it is 7 p.m. You work on something else, you check the time, it is maybe 7:40. Next time, it can be 8:30. Next time, it can be maybe 8:55. And then, later on, you check maybe it's already 9:15. So, here you're checking every time. It's like polling mode. Every time you're checking, if you have exceeded 9 p.m., basically you're going to go back home. You're checking it every time. However, the interrupt mode would be like you configure your alarm clock. So you configure an alarm clock and you let the alarm clock ring at 9 p.m. It means you proceed on as per normal. You don't even check the clock, but at 9 p.m. something can ring or some alarm can happen. So it's like an interrupt to tell you that something needs to be done at 9 p.m. So that's the difference between polling. In polling mode, you keep checking for the condition. In interrupt, if something happens, it will let you know. So that's the difference between polling and interrupt. Let's have a look at interrupt in greater details now. How can we configure SW3 to make use of interrupt? So let's say in my program, I have all these instructions. Or maybe, let's remove all these instructions. Let's not have anything there. So in my LPC Expresso, for example, in the while loop, let me remove everything. Okay, so my while loop is empty. My program is doing nothing continuously. But I can still check whether SW3 has been pressed or not. How do I do that? First of all, let's have a look at SW3. So SW3 is connected to either BLEN or PIO29. So it should be switch SW3. Once again, you have the possibilities BLEN and PIO29, which correspond to P0.4 and P2.10. So BLEN, in case you have forgotten, you can always refer to the pin mapping. In the pin mapping, BLEN is P0.4. So we need to configure P0.4 before we can trigger an interrupt from it. Okay, maybe let me draw a clock diagram. You have your LPC 1769 development board. Okay? You have many pins. One of these pins may be here, P0.4. It is connected to a switch, SW3. Now, you can configure PW4 such that when your switch is pressed, a signal will be sent. What kind of signal? Well, an interrupt signal Let's say it is a GPIO interrupt which occurs. Now, you may recall that GPIO interrupt is part of EE2024E. Okay, what does this mean? Now, 1769 can have interrupt from many sources. It can come from timer 0, it can come from maybe I squared C 0, maybe I squared C 1, or maybe it can come from something else, maybe EI&T 0, EI&T 1, so on. It can also come from external interrupt free. Of course, if you proceed on, you have many others, including USB interrupt, ADC, and so on. Now, if you look at it, there is no block for GPIO interrupt. This thing does not exist. Instead, the GPIO interrupt is part of EI&T3, or rather, it shares the same space as EI&T3. So you have your GPIO interrupt. And somehow, this has a connection to SW3. If it is P0.4, P0.4. So whenever you press your switch, an interrupt will occur here. When an interrupt occurs here, your EI&T3 handler will happen. A handler will happen. Basically, this is a function. Every time there is an interrupt, the result is that a handler function will happen. So if I press my SW3, a handler function called EI&T3 handler will occur. And it is using GPIO interrupt. Since we are using GPIO interrupt, let us configure our SW3 as GPIO. So we need to configure P0.4 as GPIO. So let us do that. First of all, let's configure P0.4 as GPIO. So I will use these things once again. And I will configure it. So I will say port number 0, pin number 4. I will configure it as GPIO. Okay, so P0.4 has been configured as GPIO. And I will tell it become an input. P0.4 is an input. P0.4 as an input here. So we have configured our SW3 as a GPIO input. Now, let us enable our interrupt for P0.4. We need to enable it because it doesn't know whether you need to check for interrupt or not. So let's enable the interrupt. Well, the enable thing is done once. Meaning for our LPC, we will use GPIO. Okay, LPC GPIO. Sorry. Let me just copy it. It's going to be easier. Okay. Hello. See that? So I will just copy it to make life easier. So I will have my GPIO interrupt port 0, pin 4, interrupt enable for the rising edge. Okay, so port 0, pin 4, interrupt enable rising edge. So I have enabled my interrupt. Now there's a difference. This is a O, this is a 0. It's different. So I have enabled my GPIO interrupt. So it means this thing has been enabled for interrupt. It can now detect interrupt sources. Furthermore, we need to enable this EINT3 itself. Okay, so we have to enable EINT3. Let us enable it. We will make use of NVIC enable. What do we need to enable? Well, it is a EINT3 free IO to N. Okay, sorry, I'll just put 21 here. So this one will enable your EINT3, or if you want, you can write it in this way, EINT3 IOQN, because this one, the value is 21. So it doesn't matter whether you put 21 here or this value. You will now enable your EINT3. So GPIO interrupt has been enabled, EINT3 block has been enabled. Now whenever it detects that SW3 has been pressed, we need to do something. So we need to create a function which tells it what you need to do when you detect this interrupt. So let's create a function which we will call void EINT3 handler. Okay, so this is your function. Let me see if I type it correctly. EINT3, okay. Sorry. We can find it in the LTC. LTC. Never mind. I will just copy it here. You can copy that. Okay. So you have your EINT3 IOQ handler. Whenever the interrupt is detected, you want to do something. Maybe I will try printf. I will tell it for test purpose, I will say printf inside EINT3 so that I know I am here. Maybe I put one more line, just a new line. Later on, things will become clearer. So, whenever I press my SW3, it must do at least this thing. Let us check whether this works before we write anything else. We should do things step by step. Don't try to write everything and test. So right now, let us test this step first. We will debug. Let's see if we have any syntax error. Okay, one syntax error. So let's see, what does it say? Okay. Okay, wrongly typed. Should be IOQ handler. NBIC IOQ. So let me check it again. Okay, that's better. So I will debug the project. So right now, I press play. Let us see. Inside our program, there's nothing. There's nothing being done. Let me try to press SW3 to see if something can be printed. So I will press my SW3, and you have this thing which happens continuously. What is happening here is, when you had pressed SW3, an interrupt signal was set. So here, an interrupt flag was set to 1. Okay? So it means after you have printed your things, it is still 1, it has never changed. You have printed something, you went back to your main program. Again, the interrupt is detected because it is still 1. So it prints something again, it goes out, it's still 1, it's still print. So this goes on forever. So this means if you want it to happen just one, you need to make the value become 0, right? So let us include a clear instruction here. So over here, let us clear the instruction. Okay. So I will have the set of instructions over here. I'm dealing with P0.4 for the rising edge. So I will make use of this. I will try to clear, let's say, number 4. Okay, it's exactly the same as what you have over here. So P0.4, similarly here, P0.4, I should actually clear it. Okay, so interrupt clear. I will clear the interrupt for P0.4. So let us try to run this before we proceed on. So I'll try to press it and see what happens. So I will press SW3 once, it gets printed once. Next time I can press it again, it gets printed again. Every time I press, it will be printed. Okay? So that's the interrupt part. It is for SW3, but this is currently incomplete. There are other instructions you need to place here. But for now, before we go there, I will let you try this. So maybe let me give a quick recap of what happened here. So we had said that in polling mode, things will be done sequentially. From in the while loop, it will be done sequentially. In interrupt mode, no matter where you are inside your program, the interrupt can happen as long as this has been enabled. So it means from here onwards, the interrupt can occur after you have enabled it. So when your interrupt, or rather, before the interrupt can occur, you need to configure it. So let us configure it. For example, if I'm using P0.4, I need to configure P0.4 interrupt enable for the rising edge. Okay? Then we enable the EE2024E IRQ, which is the interrupt request number for EE2024E, meaning this big block. We will enable it. After it has been enabled, whenever there is an interrupt from this board and pin, it will trigger this handler function. And whatever you have written inside will happen. For example, printf, print a new line, meaning this empty thing. Then it will clear, you can clear the interrupt so that this flag becomes 0 and it is not triggered again until you press it again. So you clear the interrupt for P0.4 interrupt clear. And like I said, this is not complete. We will complete it in the second briefing. But two more things before you go. This one is number 21. Okay. In case you did not realize it, it is inside your user manual, NVIC, meaning chapter 6. If you look for EE2024E, which is shared with GPIO interrupt, it is interrupt ID 21. Okay. So you can either write 21 or you can write the other EE2024E IRQ something. So we have enabled EE2024E so that we can detect GPIO interrupt. Let's go back to our program. And one other thing you will realize here is we used rising edge. Why is that? What do you think rising edge is? Let me press and hold my SW3. What do you think will happen? So SW3, I press and I hold. What do you think is happening here? Well, nothing is happening, but when I release it, okay, it's still not happening because I stopped it. Sorry. So it's the wrong thing. Let's see again. So I press it, I hold it, nothing will happen, right? If I release it, something gets printed. Why is that happening? Maybe briefly I will tell you. We have enabled the interrupt for rising edge, which is here, rising edge. Rising edge, by default, we mean that the interrupt will be enabled at the rising edge, right? Is that what everyone understands? Well, that is true for active high signal. So this is your rising edge. When you declare the rising edge there, it is for an active high signal. However, by now, you should have known that your SW3 is an active low signal. So if you look here, it is an active low signal because when you don't press the switch, you have 5 volts and 3.3 volts which is coming here. So by default, if you don't press it, it is detecting a high value. So your SW3 actually is active low. By default, it is like this. And the rising edge actually is here. Basically, when you're releasing the switch, because here you're pressing, here you're holding, here you're releasing. And you told it to trigger the interrupt at the rising edge. But for an active low signal, the rising edge occurs when you release it, okay, not when you press it. For active high, when you press it, then the rising edge occurs. So that's why it occurs when you release your switch. So this is what I just talked about. Go on and try this, meaning enable GPIO, enable EE2024E, and write something to be printed inside. So go on and try this thing. I try to use BLEN first, okay, P0.4. Thanks.